La Niña is back. This weather pattern emerges in the Pacific Ocean. It brings changes to our climate. Scientists have confirmed its presence in 2025. There is a 59% chance it will persist. This means it could last until February or April. La Niña's effects are already being felt. La Niña events are not unusual, they occur every few years. However, each event is unique. It can vary in strength and duration. Understanding La Niña is crucial. It helps us prepare for its impacts. La Niña affects weather patterns globally. It influences temperatures and rainfall. These changes have far-reaching consequences. They impact agriculture, ecosystems, and human societies. La Niña is characterized by cooler than normal ocean surface temperatures. This phenomenon is a significant climate pattern that can have widespread effects on global weather. It is the counterpart to El Niño, which is known for warmer ocean temperatures. Together, these two phases form the El Niño Southern Oscillation Cycle, or ENSO, which plays a crucial role in climate variability. This cooling occurs in the central and eastern equatorial Pacific Ocean. These regions are particularly sensitive to changes in ocean temperatures, and even slight variations can lead to significant shifts in weather patterns. The central and eastern equatorial Pacific are vast areas that stretch thousands of miles, making the impact of La Niña far-reaching. These changes are not random. They are driven by complex interactions between the ocean and the atmosphere. Scientists study these interactions to better understand and predict the effects of La Niña. The relationship between the ocean and the atmosphere is dynamic and constantly evolving, influenced by various factors such as sea surface temperatures, wind patterns, and atmospheric pressure. Normally, trade winds blow from east to west across the Pacific. These winds are a critical component of the Earth's climate system, helping to regulate temperatures and distribute heat around the planet. The strength and direction of the trade winds can have a profound impact on ocean currents and weather patterns. These winds push warm surface waters towards Indonesia and Australia. This movement of warm water is essential for maintaining the balance of the ocean's heat distribution. When the trade winds are strong, they effectively transport warm water westward, creating a temperature gradient across the Pacific. During La Niña, these trade winds weaken. The weakening of the trade winds disrupts the normal flow of warm water, allowing cooler water to dominate the central and eastern Pacific. This shift in wind patterns is a key indicator of the onset of La Niña conditions. This allows cooler water from the depths to rise to the surface in the central and eastern Pacific. This process, known as upwelling, brings nutrient-rich water to the surface, which can have significant ecological impacts. The cooler surface temperatures can affect marine life, fisheries, and even the global carbon cycle. This cooling has a ripple effect on weather patterns worldwide. The changes in ocean temperatures can influence atmospheric circulation, leading to shifts in weather patterns that can be felt across the globe. Regions far from the Pacific can experience altered rainfall, temperature extremes, and even changes in storm activity. The cooler waters in the Pacific impact the atmosphere above. The interaction between the ocean and the atmosphere is a two-way street, with each influencing the other. Cooler ocean temperatures can lead to changes in atmospheric pressure and wind patterns, which in turn can affect weather systems. This affects the jet stream, a band of strong winds high in the atmosphere. The jet stream plays a crucial role in shaping weather patterns, acting as a boundary between different air masses. Changes in the jet stream can lead to shifts in weather systems, influencing everything from storm tracks to temperature distributions. The jet stream, in turn, influences weather patterns across the globe. Its position and strength can determine the path of storms, the distribution of precipitation, and the occurrence of extreme weather events. Understanding the impact of La Niña on the jet stream is essential for predicting its effects on global weather. La Niña typically brings cooler global temperatures. This is a general trend. However, the cooling effect varies across different regions. Some areas may experience more pronounced cooling than others. The cooler Pacific Ocean temperatures influence atmospheric circulation patterns. This can lead to cooler air masses being transported to different parts of the world. The North American continent often experiences colder winters during La Niña years. The cooling effects of La Niña are not uniform. While some regions experience colder temperatures, others may see warmer than average conditions. This highlights the complex and interconnected nature of our climate system. La Niña doesn't just affect temperatures, it also significantly alters precipitation patterns. Some regions experience above normal rainfall, others face drier conditions. The shifts in atmospheric circulation caused by La Niña influence the distribution of moisture. This leads to changes in rainfall patterns across the globe. These changes can have significant impacts on agriculture and water resources. Southeast Asia, Australia, and parts of South America often experience increased rainfall during La Niña events. This can lead to flooding in some cases. However, it can also be beneficial for agriculture in regions reliant on monsoon rains. Section 5. Drought-prone regions. While some areas see increased rainfall during La Niña, others experience drier conditions. The southwestern United States, parts of South America, and Eastern Africa are particularly susceptible to drought during La Niña events. The altered atmospheric circulation patterns during La Niña can suppress rainfall in these regions. This can lead to prolonged periods of dry weather, depleting water resources and increasing the risk of wildfires. The impacts of drought can be severe. It affects agriculture, ecosystems, and human health. Understanding these patterns is crucial for developing strategies to mitigate the risks associated with La Niña-induced drought. Section 6. The peak of La Niña 2025. This section delves into the anticipated peak period of La Niña, a climatic phenomenon that significantly influences global weather patterns. La Niña conditions are expected to be strongest during a specific period. This period is characterized by cooler than average sea surface temperatures in the central and eastern tropical Pacific Ocean. This peak is predicted to occur between December 2024 and February 2025. During these months, the climatic effects of La Niña are expected to be at their most intense, influencing weather patterns across the globe. During this time, the cooling of the Pacific Ocean is expected to be most pronounced. This cooling effect can lead to significant changes in weather, including shifts in precipitation and temperature patterns. The peak of La Niña doesn't necessarily mean the most extreme weather events will occur then. However, it does indicate a period when the likelihood of such events is higher due to the favorable atmospheric and oceanic conditions. However, it's when the atmospheric and oceanic conditions are most favorable for La Niña-related impacts to manifest. These impacts can include increased rainfall in some regions and droughts in others, depending on the geographical location. Monitoring and predicting the peak of La Niña is crucial for preparedness. Scientists and meteorologists use advanced tools and models to forecast these conditions accurately. It allows communities and governments to take necessary precautions and implement measures to minimize potential risks. By understanding the peak period, they can better prepare for potential impacts, ensuring safety and reducing damage. Section 7. Transitioning to neutral conditions. La Niña is not a permanent state. It is a phase in the natural cycle of oceanic and atmospheric conditions. Like all weather patterns, it eventually transitions. This transition is a gradual process, influenced by various climatic factors. Current predictions suggest a shift towards ENSO-neutral conditions. Meteorologists use advanced models and historical data to forecast these changes. This transition is likely to occur between March and May 2025. During this period, we can expect to see a gradual shift in weather patterns. ENSO-neutral conditions refer to a state where neither El Niño nor La Niña is present. This means the ocean temperatures in the central and eastern Pacific are close to average. During this phase, the Pacific Ocean returns to a more neutral state, with neither excessively warm nor cool temperatures. This balance can lead to more stable weather patterns. The transition to ENSO-neutral conditions doesn't mean weather patterns will return to normal. Weather is complex and influenced by many variables. It is influenced by numerous factors, including atmospheric pressure, wind patterns, and ocean currents. However, the shift does signal a change in the dominant drivers of global climate patterns. This can have significant impacts on weather around the world, affecting everything from rainfall to temperature. Understanding these transitions helps us prepare for the changes in weather that can impact agriculture, water resources, and daily life. Ongoing research and monitoring are crucial in predicting and adapting to these changes, ensuring we can mitigate their effects on our environment and society. Section 8. Understanding our changing climate. La Niña is a natural climate pattern. However, its occurrence and intensity can be influenced by climate change. As our planet warms, understanding these patterns becomes increasingly important. Climate change can amplify the impacts of La Niña. This can lead to more extreme weather events. These include droughts, floods, and heat waves. Understanding these connections is crucial for building resilience and adapting to a changing climate. By studying La Niña and its impacts, we gain valuable insights into our planet's climate system. This knowledge empowers us to make informed decisions. It helps us protect communities and ecosystems from the challenges of a changing world.